Okay, so let's go ahead and take a look at this section. So this one is chain rule with logs and trig, but I can also find the derivative at a point. So first, I f prime of x is the outside is the a to the x times ln of a. So this is 4 to the 1 over, x times the ln of 4. That takes care of the outside function of 4. Now I have to take the derivative of 1 over x, which is the same thing as x to the negative first power. So this is negative x to the negative second power. And then I want this evaluated at 2. So f prime of 2 is 4 to the 1/2 ln of 4 times negative 1 over 2 squared. So this gives me, let's see, so 4 to the 1/2 gives me 2. And then I am multiplying this by negative 1/4. So then the 2 and the 4 reduces. So this gives me negative 1/2 ln of 4, which properties of logarithms state that this becomes the exponent. So this is ln of 4 to the negative 1/2. So this is ln of 4 to the 1/2 in the denominator, which is ln of 1/2, which is the ln of 1 minus the ln of 2. So ln of 1 is 0, so this is just negative ln of 2, which is this one here. Okay. Question 2, question 3. Same idea, so f prime of x, 5 to the 3x ln of 5 times by the derivative of 3x, which is 3. So we can group these. I looked to see if my answer that I had was there, and it's not. So then I can have 5 to the 3x, and I can, multiplication is commutative, so I can, put parentheses like this and go 3 ln of 5, and then the 3 becomes the exponent of 5. So this is 5 to the 3x ln of 5 cubed, which is f prime of x, is equal to 5 to the 3x ln of 125, which is that one there. Okay, question 3, question 4, question 5. So here, the way that logarithms work is the exponent can come to the front here. So this is 2x ln of 5. And then the ln of 5 is just a constant, and so is 2. So then this is really taking the derivative of x, which the derivative of x is 1. So this is just 2 ln of 5. The 2 can become the exponent here, so this is the ln of 25. Or 2 ln of 5. Should have looked before I got crazy with my properties of logarithms. Okay, that's question 6. Question 7 is a product rule with chain rule. And so just remember that 1 over x is x to the negative first power. So this is y prime is equal to e to the 1 over x times by the derivative of x squared, which is 2x plus x squared, times the derivative of e to the 1 over x, which is e to the 1 over x times negative x to the negative second power. Okay, so y prime is 2x e to the 1 over x minus. So this is, I'll just put it as plus x squared 1 over x, and then this is negative 1 over x squared. Okay, so the x squareds cancel out. Then I'm left with a negative, so this is y prime is equal to 2x e to the 1 over x minus e to the 1 over x, which has a common 1 over x, so I have y prime is e to the 1 over x, and then I'm left with 2x minus 1, which is that one there. Okay, 7, no question. 8 or 9, so we'll move right along to this one. So y prime outside is sine, so the derivative of sine is cosine, 5x minus 1, times by the derivative of the inside, which is 5. So y prime is actually 5 cosine of 5x minus 1. If you don't put a double parentheses here, it would be incorrect unless you move the 5 automatically to the front. Okay, so y prime, derivative of tangent is secant squared, 9x plus 2, times by the derivative of 9x plus 2, which is 9. So y prime is 9 secant squared, 9x plus 2. Y prime outside is tangent, so that's secant squared of secant x, times by the derivative of secant, which is secant x tangent x. And again, double parentheses, because otherwise what it says is that this secant x tangent x is being multiplied by the angle measurement, which is secant in there. This is chain rule. This is cotangent of x, the quantity squared. So y prime is 2 cotangent of x times by the derivative of cotangent, which is negative cosecant squared of x. So y prime is negative 2 cotangent x, cosecant squared x. 9, same idea. This is the cosine of pi x, the quantity cubed. This is double chain rule, meaning I have to do chain rule twice. So I bring the 3 down, cosine of pi x, and then this is to the second power. Then the next inside, so here's the 3, that was the outside. Next inside is cosine, which is negative sine of pi of x, and then one more inside, which is the derivative of pi x, which is just pi, because remember pi is just a constant. So y prime is negative 3 pi cosine squared pi x times sine pi x. And then y prime here, negative 3 tangent of x plus sine of x to the negative 4th power times secant squared of x plus cosine of x. 13 y prime outside is sine, so the derivative is cosine of 7x. This is, again, another multiple chain rule. So the first outside was sine, the next outside is cosine, which is negative sine of 7x, and then times by the derivative of 7x, which is just 7. So this is y prime is negative 7 cosine of 7x times sine of 7x. 15 is the last one. So this is another multiple chain rule one. This is cotangent of 4x plus 1 to the 3rd power. So y prime outside is 3, the 3rd power, cotangent 4x plus 1 squared times the derivative of cotangent, which is negative cosecant squared of 4x plus 1. And then the next inside, which is the derivative of 4x plus 1, which is 4. So I just work my way inside, just like those, like little dolls that keep getting smaller. So I go cubed, then cotangent, then 4x plus 1. So then I can combine this, so y prime is negative 12 cotangent squared of 4x plus 1 times cosecant squared of 4x plus 1. Okay? And that is it for this section.